Okay, so this week we're going to be talking about graphing and microscopes. That's one of our goals, is to help you guys become better at graphing, interpreting them, reading them, and creating them. And then as we get into our cells unit, we're going to be working a lot with microscopes, so we're going to do some introductory activities. Okay, so first thing we're going to talk about Objective 25. I can identify the parts of a graph. So the things we need to remember when we're creating our own graph, we need to have all of these different parts. So the first part right here is a title. You want to title your graph, okay? That tells people what your graph is telling them, okay? If we don't have a title, we have no idea what the graph is telling us. The second thing down here is to label our x-axis. That is our independent variable. Remember, that is the thing that the scientist controls. So in the case of this line graph here, it's the year, and in this bar graph, it is kinds of ice cream. Okay? The third thing is the y-axis label, or the dependent variable. That is what you are measuring. So over here, when we're talking about the value of Sarah's car, the thing that she controlled was the year. Okay, so as it got older, what happened to the value of her car? So we want to know what is the thing that we were measuring. For our favorite ice cream, we were measuring the number of votes. Okay, that's the third thing. The fourth thing is our x and y axis scales. Okay, you can see here we are starting at 0. You're always going to start at 0. And then over here we have the year, starting with 2001. That was the first time. And up here, going up, we have the value in dollars. And again, we're starting at 0, we're increasing. Over here, our x-axis scale is just the different types of ice cream, and then this was the number of votes, again, starting at 0. Okay, and I have lots of writing all over the place, so let me erase that so you can kind of see what's going on here. Okay, and then the last thing that we are going to have, obviously, are our data points. So these are our data points. Okay, all these different points, and then for a bar graph, they go up to a certain place, and then we draw our lines down and we fill those in. Okay, so those 5 things are super important for every type of graph, that you have all of those parts. Okay, all right, so Objective 26 is I can choose the appropriate graph to create based on my data. So based on whatever it is that you have is the type of graph that you're going to have. All right, so 3 types of graphs: bar graphs, line graph, circle graph, or it's also called a pie chart. So what we need to remember is when we are making a bar graph, it's because we're comparing 2 or more things. Okay, you're just comparing them. When we're using a line graph, it is showing a change over a period of time. Anytime your data shows that you are measuring something over a period of time, I don't care if it is seconds, minutes, hours, years, decades, centuries, millions of years, it doesn't matter. If it is a period of time, you use a line graph. Again, a period of time, you are using a line graph. Okay? And then the last thing, the circle graph or the pie chart, that is to show parts of a whole. Okay? It's usually expressed in percentages, and all of those percentages have to add up to 100%. Okay, it can't be over because a whole is 1 or 100%. So it's, again, it's called a pie chart because it's like a piece of the pie. Okay? All right, so let's start with a bar graph. Here we go. Oh, we're still behind. What is going on? There we go. Okay, so this is a bar graph, and again, we have our title. Here we have our y-axis labeled. Our x-axis is not labeled. Something's missing. So what would we put here? We would put ice cream. Okay. And we have our x and y axes labeled, and we're starting at 0 there. Okay, so this data that this graph is showing is the exact same data that is in our data table. 7 people said that they liked cherry, 3 people vanilla, 7 people chocolate, 5 people mango, 3 people pecan, and then 6 people berry. What this graph does for us is it tells us right away, if we are looking at this, we can say, oh, The most people liked cherry and chocolate. Okay, we can see those two right there because they are the tallest. It is comparing all of the different types with berry in a close second place. Okay, so you are comparing two or more things here. Okay, moving on to a circle graph or a pie chart. A couple different things that you're looking at when we are talking about a pie chart. First of all, you should definitely have some kind of title. Okay, that's telling the person who's looking at it what it is that you are showing them. And you are either going to have all of your data here. You can see that they have, this is student grade, so there was 4 kids who got an A, which equates to about 14.3%. So they have what the category is, so this is an A, and they have the percentage here, okay? They could just put, hey, this is A, this is the kids that got a B, these are the kids that got a C, and these are kids got a D. And because it's in a pie chart, we can determine ourselves the actual percentage, but they tell us what the percentage is here, so we don't have to do that, okay? If these, like in this case over here, these categories right here are not labeled, so we have to have some type of key, okay? So you can do it either way. So this light blue color here is sleeping, this is our eating, homework, time spent in school, sports, and then this is leisure, which means doing whatever they want to do, okay? So make sure if you're creating a graph that you either have some type of key or that you have labeled it over here, okay? Moving on. All right, line graphs are going to show a change over a period of time. Again, remember that I told you it doesn't matter what your period of time is, minutes, seconds, hours, days, months, years, decades, centuries, it doesn't matter. If it's a period of time, you have a line graph. Again, these are all the different parts you need. Title, labeling on the X and Y axis, your scale starting at 0, okay, and then your data points, and then line segments to connect your data points, okay? Let's look at some different types. This line graph that is coming up, there it is a double line graph, and it's called that because there's 2 sets of data. So we can graph more than one set of data on the same graph, and the first thing that we need is that we need to have a key. Okay, our key is going to tell us our lines apart. So sometimes they're different colors. Sometimes you can tell because people will use different shapes to represent your data points. So we could, if this was in black and white, we could say, oh, okay, our blue or our company A is represented by our star shape, while our company B is represented by the square shape. So it doesn't matter, just as long as you have some kind of key to tell them apart. And the other thing that I wanted to show you that was really important is that points from different lines, so our company A and our company B are sharing this exact same spot. So in 2004, 2005, company A and company B both had a $4 million profit. Okay, there is only one place on this entire graph that is for 2004, 2005 and a $4 million profit. It's right there. So you can see both lines going to it. However, there's only one spot. We don't put it next to it. We don't put it above it. We don't put it below it. They share the exact same spot. So you can see here that points from different lines can share the same location. A lot of people make that mistake, and it's okay, but I'm telling you now, so you don't make that mistake, that they can share the same spot. Don't put it above or below. Just they go right in the same spot. There's only one location for that. Okay. Oh no. Okay, continuing on. Objective 27, we're going to look at some different types of graph, and we're going to describe what's happening based on the shapes. You can see with this graph that the line is straight across. That means our distance is staying exactly the same even though our time is increasing. Okay? So basically, whatever is whatever they're graphing here, the object, it's not moving, it's at rest. Because the distance is staying exactly the same. That means it started at this distance and it's staying right at this distance even though time is increasing. Okay, let's look at the next one. This graph is showing that as time is increasing, so is our distance. Okay, so as our time is going up, our distance is going up. And because it's going at this nice evenly slanted line, it's saying that it's a constant, that it's not changing. Your speed is staying exactly the same. As your distance increases, your time is increasing. So basically this car is traveling, it shows that it's traveling at a constant speed. Okay? Objects, right here, the graph shows that object's distance increases as time passes. The object is moving, and so it has a velocity, and it has a constant velocity. Okay? Here we go. Just like the previous graph, the one right before, this one is also moving at a constant velocity. This time, as we have our time increasing, our distance is decreasing. So we started at this distance, and now it's basically like we are slowing down. Okay? This next graph is interesting. We have acceleration going on here. The curve in the graph shows that the object's velocity is changing as time passes. So what happens is, as our time is increasing, we start out at one velocity, and then all of a sudden it kind of takes a spike as we're going. Our distance increases. All of a sudden we have this sharper turn, this curve that's happening right here, which means we were going a nice constant velocity, and then all of a sudden we stepped on the gas and we went a further distance in a shorter period of time. Okay? That's what that graph is showing. So our graphs can tell us different stories. Okay? If we look at this graph, we can see in this first part of the graph right here, we see that we're moving, we're accelerating with a constant velocity. And then all of a sudden our distance stops going up, but our time continues to increase. So that means that our object is at rest. And then in the third part of the graph right here, we can see that our distance again is decreasing as time increases, which means we are basically slowing down. So we're going to increase, we're going to go constant, we're going to be at rest, we're not going to move, and then we're going to decrease. Okay, so that graph shape is telling us a story. So we're going to try our own little story and do our own graph with this story right here. So see if you can follow along. Alright, Johnny's mother brought him to school and then came back home for 3 hours. So they were at home, they went to school, and then she came back home for 3 hours. What is going on here? Alright, let's try again. Alright. Johnny's mom went to school, brought him to school, and then came back home, and she stayed there for 3 hours. So she went to school this way, she came back home, and then she stayed there for 3 hours. So this is time, this is distance. Sorry, this writing is awful. Okay, then she went to the store for 2 hours, which was on her way to Johnny's school. It says she was there for 2 hours, so she was there for 2 hours. After she was done shopping, she continued to Johnny's school to pick him up, and then, that's a little bit too high, because the school should be the same distance across as we are over here. She went to Johnny's school, and then she went back home. Okay, so I don't know if you guys can follow that. I'll try to go over it in a different color real quick so you can see it again. Alright, Johnny's mom went to school to drop him off, and then she came back home. She stayed there for 3 hours. These are the 3 hours that she stayed home. Then she went to the store, which was on her way to Johnny's school, and she was shopping for 2 hours. So she stayed there for 2 hours. Then she went to Johnny's school to pick him up, and then she came back home. And that's where she stayed for the rest of the night. Okay? Hopefully you guys can follow that little story. We're going to be working on these in class, so if you don't get it, we'll work on it in class. Okay, moving on to microscopes. Here we go. Objective 28 is I can identify the parts of a microscope. So here we go. You will need to label these on your guided notes. Alright, we are going to start with the ocular lens or the eyepiece. That's the part you look through on most of ours. We have 2 of these tubes coming up, so you can use both eyes, but some of them are just one. Then we have the body tube, the nose piece, which holds all of the objective lenses. There are your objective lenses. Usually there's 3 of them, low, medium, and high power. Your stage clips, which hold your slides in place. Your diaphragm, which changes the amount of light that is getting to your slide, so you have like little holes to bigger holes, and we'll be taking a closer look at this. The diaphragm adjusts the amount of light that is coming into your slide. Then you have your light down there at the bottom. Your arm, which is part of where you are holding when you're carrying your microscope, and again, it's holding your ocular lens and your nose piece. Your stage, that's where you put your slide. Then you have your, why did that not show up? You have your coarse adjustment and your fine adjustment. And your base, which didn't show up. So let me see if I can write those in for you. Oh, there's coarse adjustment. That showed up. Of course, we are having technical difficulties. It wouldn't be... There we go. There they all are. Okay, so you have coarse adjustment here, which is just used under low power. That moves this entire thing right here up and down really fast. And then we have our fine adjustment, which moves that up and down really, really slowly. And then our base. And you can see here it says, always carry a microscope with one hand holding the arm and one under the base. And we are going to look at that. Okay, so you can see in this picture, letter A on the left-hand side, this is how we correctly carry one hand on the arm, one hand on the base, and you carry it close to your body. This is the wrong way to carry a microscope. Okay? One hand on the arm, one hand on the base, and close to your body. Objective 29, I can follow the steps to use a microscope correctly. Step 1, we are always going to observe using the lowest power objective first. So when you get your microscope out, if it is not automatically on lowest power, you need to put it on lowest power. Then we are going to focus under low power using the coarse objective, and of course more technical difficulties. Okay, here we go. We're going to focus using the coarse adjustment knob to bring the object into focus. We're going to use it to bring it into sharp focus. So basically when we can see it really, really well. And then we are only going to use the coarse adjustment knob. That's the bigger knob on low and medium power. We do not use it on high power, because if we do, we're gonna break those glass slides, and we could also damage the microscope, and we don't want to do that. Okay, we're going to focus first on the lowest and then move to a higher power. So you're going to focus on low, then move to medium, get focused on medium, and then move to high. You don't go from low to high, and you never start on anything except low. You always start on low first. You're going to use, step 4, use the fine adjustment knob when using the highest power objective only. Number 5, keep both of your eyes open to reduce eye strain, and it's a lot easier too. Like I said before, a lot of our microscopes have the double tube, so you can look through with both eyes. And then number 6, you're going to determine total magnification of the object by multiplying the power of the ocular or the eyepiece, which is 10, by the power of the objective, and we're going to talk about that in 1 second. Here it is. I can calculate the total power of each objective lens on the microscope. So to calculate the objective lens on the microscope, we are going to multiply by the power of the ocular lens. And so you can see here, where's my little circle? There it is. You can see here that this is our 10 times. That is our eyepiece, or our ocular lens. And this is the power on the objective. So those are the numbers you're looking for. So on our microscopes, we have our eyepiece, again, is 10 times, and our low power is 4 times. So we're multiplying 10 times 4, which is 40 times. Okay? Our Medium power is 10 times on our eyepiece. Medium power is 10 times, so 10 times 10. So medium power is 100 times magnification. And on high power, we have 10 times eyepiece, 40 times high power. So 10 times 40 is 400 times magnification on high power. Okay, so when we are looking at, when we're comparing, basically what we're saying is at a lower magnification, for example, on this one right here, at 7 times, we're seeing more of the picture, but we're not seeing it as detailed. As we increase our magnification, we're seeing less, but we're seeing more details. Okay, so the more you magnify it, the more details you're going to see. Okay, so if you look at these pictures down here are both of the same exact thing. So one's on low, one's on high power. Okay, you can see this one, we're seeing more of what's going on. That's low power. This one's high power. Okay, we are seeing more of those details. We're seeing those little dot blobs right there, nice and close up. Okay, moving on, we're almost done. We need to talk about how to make a wet mount, and we're going to be doing that in lab this week. Okay, so I can describe the steps to make a wet mount slide. Step 1, get a clean slide and cover slip from your teacher. Okay, the slide is the glass thing, and then the cover slip is this little square plastic, and it's clear plastic piece that goes over top of the slide. Okay, so before you put the cover slip on, you're going to place 1 drop of water in the middle of the slide over your specimen. So the first thing we're going to do is a letter E lab. So you'll have a little letter E, and you're going to put the E on your slide, and then you're going to put a drop of water on top of it. You're not going to use too much water, just 1 tiny little drop. And then you're going to place the edge of the cover slip on one side of the water drop, just like this picture over here, you can see. And you are lowering it slowly at an angle, and that is going to help you avoid getting air bubbles underneath. And then you place the slide on your stage. To view it first, it says with the red banded objective, that means the lowest objective. Once you see the image, you can rotate the nose piece to view the slide at the different objectives. So again, we're going to start at low power, get it in focus, then we can switch to medium power, get it in focus, and then switch to high power. Okay? And you don't need to use stage clips when you're doing wet mount slides, because you don't want to mess up your wet mount by trying to get those stage clips on your slide. And last but not least, when we are finished with our microscope, we're going to return it to the lowest power objective. So return it to low power, unplug and wrap the cord around the base, and then we're going to put the dust cover back on top of it. Okay, and that is all for this week. All right, see you in class.